Okay, we're on page 148. I asked you to work on those questions there. I'm assuming you're all done, right? So let's go over it quickly, and then I'll cover some new stuff, and then we're good to go here. So you have the grocery store. They sell toothpaste, and you've got 75 of brand A, 23 of brand B, 57 of brand C. What's the probability? I want to start talking about odds already. And I'm going to dedicate more time on it later. So that's going to be new. So if you're not paying attention now, you're going to struggle with it, okay? But what's the probability of a customer buying a tube of brand A? So probability, you will take brand A over what? What always goes in the denominator of a probability? Total, okay. Because that's going to make the difference between probability and odds, okay? So we've got brand A is 75 over, I'm going to actually show what I'm doing here, okay? I'm figuring out the total there. And what do I get? I get 75 over 155, yeah, which is 0.4839 as a decimal, which is 48.39%. That wasn't necessary, but you should be able to do that. No problem, right? From here, I can get my odds. So let's take Amazon. Your lead is not really good. Okay, let's turn this into odds. Let's do that right now. Odds, we write them like this. Okay, so what you would do is you would take the 75. Odds of somebody buying brand A is 75. Put that down here. Highlight it. And what goes on the other side? 155 is the start, but not the end. What are we comparing if we're doing odds? Brand A, oh sorry. Right, which can I call it not brand A? This is brand A, and this is not brand A. Right, so you're gonna take the total, and what are you gonna subtract from it? You're gonna subtract all the brand A tubes from it, and that's gonna give you everything else that we are considering. Does that make sense? Sort of. I need more examples, Mr. Dirksen. Coming right up, right? So what do we have here? Minus 55, that'd be 180. So this, I will not reduce anything right now. Like, I don't want to deal with reducing right now. I just want you to understand the concept. Look at brand B and C. If you add them up, what do you get? 23 and 57. That's 80, right? And that's what you have here. Okay, so you're comparing brand A to not brand A. A to not brand A. Okay, that's what you're always doing when you're doing odds. It's just a different way of talking about it. Let's see here. If a store sells 500 tubes next month, how many brand B can they expect to sell? You're making a prediction here. Write this down. You're making a prediction on a larger scale. So prediction, this should be on your study sheet. You're going to do probability of brand B times large sample. Here it is one more time, your formula, in case you missed it. Okay. So what's the probability of brand B? How many brand B tubes are there? You're basing it on what you were given way up here. This is your small sample. Okay, 23 out of 155. Put it in brackets like this, times In this case, it's 500 tubes that we're making a prediction for. Grab your calculator with me. Like, you need to know how to type this in or else you're in trouble still. So I go 23 divided by 155, hit equals, right? Hit equals. Then you go times whatever lies outside, right? So times that. So now it's 74.19. 19, watch what I'm going to do. This is what your calculator shows you. We're talking tubes, right? You're going to say what? 74 or 75 tubes, right, of brand B. Okay. So that's what like insurance companies. Yeah. Cross multiply and divide, yes. Yeah, if you do proportional reasoning, you'll be fine. AutoPack does this all the time. They always keep track. Data is everything. AutoPack must have crazy amount of data that they collect. So they're like, okay, last winter we had, this many claims, and out of those many claims, a certain percentage were write-offs, right? Let's say 40% of collisions resulted in write-offs. And so they have to have a certain amount of money in the bank to pay out those write-offs. So they keep track of that. They're doing similar math. They're like, this is the probability of it being a write-off. If we have 5,000 claims in a certain month, that's this many cars being written off. And then they probably have an average cost for the write-off, right? Some get 5 grand, some get 30 grand. It depends on the car, right? So they have that average. And so that's how we do math all the time, okay? Let's keep going. Who did this question? Hands up. Before I do it, I want to know if you tried it. Oh man, that's a lot of hands. I can't count that high. I need a third arm. You give this a try real quick. Read it. Just the blood type for now. AB positive, 27. So go ahead. So your small sample size is the 850, right? That's the one you just collected data from, and now you're making a prediction, right? What if it's a group of 5,000 instead of 850, right? So you go prediction is 27 over 850 times the 5,000. Okay? So maybe I should just, some of you were working while I was doing this, but the first thing you should do on a table or anything is add up all of them to get your total, right? Then you dive into the individual probabilities. For O, there could have been O positive or O negative, so both of them are considered there. And it's just 1 out of 850, AB negative. Okay? You would have to concur that this is an experimental probability, correct? Experimental probability, because it's based on actually, like, out of 850 people, right? You've collected data, right? These are trials, so to speak. You're trying, right, 850 times to figure out what's what, right? So you're collecting that information, and then you're coming up with the probabilities. And so you will actually see that all of these are experimental. So here, let's answer that. 27 divided by 850, right? Times 5,000. That's 158.82. And we're talking people. So that would be about 159 people, right? If you wanted to round down to be safe, right, to say, hey, it's actually about 158, that's fine. Either one is okay when it comes to whole numbers. And let's do the book types. This is being written down, right? There you go. Also, probably that a randomly chosen student will like poetry books. I need to add this up first. Okay, so this is 55 plus another 45. That's 100 plus 4. Is that 104? Thank you. I don't have the key, so I need to. Probability of poetry. So probably, if you want to do it like textbook, they actually do it like this. Probability of this happening, you go get your poetry books, 5 out of 104. Okay, let's turn that into a decimal. That's 0.0481, which is 4.81%. Probability that it will be historical novels, probably historical novels, you can do that, HN. We've got 4 out of 104. So leave it like that. I will answer C on this page, but I don't know if you caught that there's a C on the back side. What does it say? If the school, let's see here. If the school is adding to the library and has a funding to purchase 1,000 books, how many should be science fiction? How about we just do it there? It's better. How much should be science fiction? So you're making a prediction again on a larger scale. So prediction. What's the probability of science fiction? I look and I see it's 28 out of 104. Put that in brackets like that and multiply it by 1,000. At 269.23 but we're talking books, so we're going to go 269 books will be his science fiction. Oops, right there. So I hope you understand the prediction. You need the probability, multiply it by whatever it is, the larger sample I call it. Okay. And the next pages, the next 2 pages are a little bit boring. So I will just tell you what you need to watch out for when it comes to sample size. Can you highlight sample size? Right. Or circle it if you don't have highlighters. When performing experiments to calculate experimental probability, you need to consider the sample size, right? You always need to consider the sample size. Total number of objects, events being counted. A small sample size may not give the results that are representative of the whole population. When the sample size is appropriate, the probability of the event of interest will be the same in the sample size as in the population as a whole. Okay, so when it comes to sample size, I will say this: sample size, write this down on the margin there, right? Greater is better. Okay, greater is better when it comes to sample size. And another thing you need to consider is diverse. It needs to be diverse. A lot of companies, you know these scam 1-800 numbers, right? I don't even pick them up anymore. I don't pick them up. I don't care. I might be winning money. I don't care. I don't pick them up because immediately I'm thinking it's a scam, right? So they're still doing a lot of phone calls these days to ask who you're going to vote for. And so are they targeting everybody? No. A lot of people are like, so they're only targeting the people that are actually willing to pick up and say who they're going to vote for. Same thing, if you're doing a survey, you should be going to the mall. You should be going to maybe a bank if they allow you, right? You should be going to maybe to a game, a Jets game, right? So you're going to get different crowds, different age categories. So when it comes to diverse, right, you're talking ages, culture, etc., right? So that's something to keep in mind as well. So when it comes to sample size, you want it diverse and you want it as big as possible. Okay. All right. We're gonna skip those questions for now. So just come with me. We're almost at the end of the day, or the period. I wanted to start theoretical probably. I will leave it for tomorrow. In the meantime, I want you to try. I'm going to tell you which questions to try. Go to 152 with me. I will circle right now before you go. Okay? I want you to try 3, 4, and 6. 3, 4 on page 152, right? 3, 4, and 6. If you want to try 6 right away, that's the hardest of them all today. Start with 6 and then work backwards. 6 is something that could be on an AC tomorrow, something like that. So 3, 4, and 6. Okay, 3, 4, and 6.